Hey, hi Sudipto. Are you able to hear me? All right, great. Let's just wait over here for 30 more seconds and let's see if someone else wants to join in. Otherwise, we'll get started in next few seconds. All right, so let's get started over here. I think we are already at the 11 a.m. mark, so I don't want to keep you waiting a lot. All right, guys, so let's get started. This is our introduction to machine learning career track. My name is Mihir Thakkar, and I'm the founder and instructor at Kodiraku. A lot of you are watching this session recorded. So just to make sure, if you haven't attended any of our previous sessions, we are an education platform which is trying to make world-class computer science and engineering education accessible to millions of students out there. In our today's class, we'll be building a digit recognition system and using machine learning. And specifically, we'll be using a method called as support vector machines, which we have studied in our previous class. We did some we went over some of the math behind it, and we tried to get some intuition behind how support vector machines work. In our today's class, we'll be applying support vector machines and building a real system that one could use to recognize digits. And the applications could be at many places in terms of, let's say, if you are doing some sort of optical character recognition, or you're transcribing old newspapers to you want to digitize them, right? So there could be many applications where you might need such a system which can recognize the handwritten patterns and transcribe it to get the digital version of it. So that is what the plan for today's class is. We'll be trying to build the system in our class over here. Let's see what do we have in the class for you. Before we go in, I want to make sure that you have these packages installed on your system. So if you don't have them, just try to run this command on your system to make sure that you have the necessary packages. I'll be waiting over here for a few seconds to make sure that you have run this command on your system. All right, so just let's make sure that you run the command and keep it going. So I see that Nitesh joined in as well. Hey, Nitesh. So we just started off with the class in terms of we are going to build a digit recognition system today using the concepts that we learned in our previous class on support vector machines. I'll be going through some revision. We'll be revising some concepts. But before that, I want to make sure that you have these packages installed on your system. So go ahead and run this command on your shell, and just make sure that you have it running, and let me know after that. You don't have to necessarily complete all the installation process. By the time we can do our revision as well. Okay, so just have the command over there, and make sure that it's executing, or you are running the shell command over there. Okay. All right, so once you have that, so we are just installing these two packages, OpenCV Python and JobLib. I'll go over these packages whenever we encounter them and when we are going to use them. So don't worry about that. Just make sure that you have these two packages on your system for now. All right, so let's see what we're going to go over today's class. First, obviously, I want to do a quick recap because it's been some time that we studied support vector machines. I'll do a quick revision. Then we'll go over the pre-processing steps for the digit recognition system that we are going to build. We know that you guys have worked a lot with text files, images. Are new thing. I guess this is the first time that we are going to process images in this class. So we'll see how what are some common steps you could use. And on the previous slide, you saw that I have asked you guys to install OpenCV, which is Open Computer Vision Library. So there are some aspects to computer vision that we'll be covering in our today's class as well. And then obviously you want to build the scikit-learn model. We'll be using the SVM. We'll be building the SVM model in scikit-learn library. So this is the step that we have done before. So nothing new over here. All right. So last time I had started out with this discussion saying we have three models over here, L1, L2, L3. And now I had asked you guys which one is a better model. Intuitively, which line do you think best separates these points? And what did you guys say? Or no, what if you haven't attended the previous class, what do you think? Is L1 a better model, L2 a better model, or L3 a better model? So Sudipto says L2. Does everyone agree with Sudipto over there? Is L2 the better model is than L1 and L3? And Nitesh says L3. And Nitesh, you are right over there. L3 is a better model over here. Because if you look at this one, L1 is definitely not separating these two classes properly. There are lot of misclassifications over here. These blue points are on the same side of the red points. So L1 is not surely a good model to build. Now we are left with two things over here, two models, L2 and L3. We see that L2 over here is slightly more towards these blue points over here. So we could say that L2 is biased towards the blue class over there, which is not something that we want, right? Intuitively, we want a line which is right in middle over here, right? Which is best separating these two classes, and it is as far apart from these two edge points over here, right? Last time I did not mention this word, but these two edge points that you see over here, this blue one and this red guy, now these are also called as the support vectors. And now you could think, now you could guess why the SVM is also called a support vector machine classifier, because it is based on the principle that it tries to find a line which is right in between these two support vectors. Does that make sense? So these two corner points, the edge cases over here, are the support vectors for this problem. And what our support vector machine classifier will do is try to find this L3. It will try to find a line which is right in between over here. And intuitively, that is what we want, right? So we want a classifier which maximizes the distance between these two support vectors. Does that make sense? Let me know if you are still with me on there. Okay. Then we went on to do some math behind our support vector machines. We wanted to formalize the problem that we have at hand, right? So what I said was any linear classifier has a form of WTX. You take a dot product of the weight vectors plus B, right? That's a linear classifier. And what I'm telling over here is we want to find a line. We are interested in finding these two lines, the green line and the blue line, such that it is at a constant distance away from this blue line. So imagine that you are standing in when you were in school, your teacher would ask you guys to stand in a one hand distance. So everyone will spread out their hands. So this is what the blue line is trying to do. It is trying to spread its hands until it reaches the red point over here and the green point over here, and then adjust itself right in between those 2 points, right? So that is what this blue point is trying to do, so that it is equidistant from both of these classes. This is what support vector machine tries to do over there. I have gone over where is this formulation coming from in terms of this is same as saying y is mx plus b. Okay, there is nothing different over here. The only difference I'm saying is, instead of two-dimensional, if you want to generalize it to n dimensions, we could also convert that to a vector notation over here, right? So this is nothing but y is mx plus b. In this case, y is mx plus b is equal to 1 on this green line. The equation of this green line I'm saying is y is mx plus b is 1, and mx plus b is minus 1, which is on the opposite side of this blue line. Okay, and this plus 1 and minus 1 are really constant over here. I'm not saying that it has to be plus 1 or minus 1. It could be plus 5, minus 5, whatever you want over there. The only thing is they both needs to be equal, right? And these y is wtx is just a vector notation of what we already know, which is y is mx plus b. The weight vectors over here will consist of the weights. In 2 dimensions, you just have one slope. In 3 dimensions, you will have parameters of that plane. And in n-dimensional space, wherein you have a lot of more features, which is generally the case in machine learning, right? You don't do machine learning if you have 1 or 2 features. You want to do machine learning when you have thousands of features. In our today's class, we'll be dealing with 784 features. I guess I shouldn't have said that, but that was one of the quiz questions as well going ahead. But here's what we did then. We said that I'm interested in finding what this distance is, right? We want to maximize the distance between the green point and the red point, or the green line and the red line. So I'm trying to find what is this distance? What does it look like? Or what is the formulation for this distance? Because if I know the equation of something, do we know how to minimize it or maximize it? Last time when we were doing gradient descent, when we had the loss function, which was the square root of the differences, right? So we were using the mean squared error. If I gave you the equation of that curve, were you able to find the minimum of that curve? What will be the minimum point on that curve? Do we know already how to do that? Right, so that is what I'm trying to do over here as well. If I know the equation of this distance, then I can apply my differentiation and get to the bottom of that convex curve over there. Right? That is what we'll try to do. And again, I don't want to use some fancy terms over here. The only thing when I say a convex term or a convex curve over there is, I mean that the curve is pretty smooth like this. Okay, it's not like this. Right? And can you think why for our method gradient descent to work, why does this curve have to be convex and not something like this one? Why do I need the first option over here, a smoother convex curve, for my gradient descent to work? Yeah, Sudipto has that exactly correct. Sudipto says that there are a lot of local minimize in this second non-convex curve, right? Which is something that you don't want. Your gradient descent will get stuck in this smaller pit, and it will never reach this global optimum over here. So for in general, our gradient descent to work, now you need this curve to be non-convex in nature, or it has to be convex in nature, right? Stochastic gradient descent that we did is actually better at dealing with the non-convex curves as well. Okay, so even if you have a non-convex curve which is not exactly smooth, stochastic gradient descent will be able to, if you choose the right learning rate, it will still be able to, reach to a global minima, which is not intended as per se. A lot of people thought that stochastic gradient descent was very bad idea back in 1980s, but that's how machine learning is. A lot of things which were considered stupid before, they started becoming, they said, okay, now we correct ourselves. Stochastic gradient descent is not that bad, even though it is computationally a little expensive. No, it works with some non-convex curves as well. Okay, so just wanted to make sure that you understand that part. Okay, so then we said, okay, let's try to find an equation of this distance over here, because if I know the equation, I know how to minimize that curve, right? So we said, okay, let's subtract the equation 1 from 2, right? That's how there are two linear equations with two variables. That's how you would find the equation x1 minus x2. You subtract these two equations. Then you're left with W transpose x1 minus x2. If I divide by the magnitude of W on both sides, okay, I'm interested in this x1 minus x2. I'm interested in x1 minus x2. I can't divide both the sides of an equation by a vector. Okay, so W transpose is a one-dimensional array of all the parameters of that plane. I can't divide both the sides of equation, the parameters of that vector, by the vector itself, but I can divide by the magnitude of that vector, right? Because this is just a scalar. So if I divide both sides by the magnitude of W, then this gets cancelled off. I'm only left with x1 minus x2, which will be 2 by W. Okay. And what I'm saying over here is nothing new. What I'm saying is that yi, the predictions can be +1 or -1, because for red points, I want -1. For green points, I want +1. And all I'm saying is every point on the left side of this green line is +1, is greater than equal to 1, right? So if you draw equation of any line which will be passing on this side of the line, it will be greater than equal to 1. And all the lines which are on the right hand side of this blue line, the red lines, will be greater than less than equal to -1, right? So this is what we are saying, that I want to maximize this distance. So I want to maximize this distance, but under the constraint that I don't make any misclassifications. So the green points are still considered green points and the red points are considered red points. So this is what I'm saying over here, that I want to maximize 2 by W, but yet make correct predictions. So this is our constraint. Okay, in mathematical terms, this is called the optimization objective. 2 by W is the optimization objective, and this is a constraint under which we need to perform this optimization. So our objective is to maximize the margin, but so to maximize 2 such that the constraint that I just showed you over there, I'm just rewriting it over here. And what I'm also telling you is you can, now if you look closely over here, if you multiply this equation, both equations by yi, you'll see that you end up with the same thing. You could now simplify this entire thing to one statement over here. So Nitesh, I think you were not there in the previous class. Go closely and look through this equation over here, and can you tell me if you agree with me on that? If you multiply yi over here on both equations, so 1 over here and -1 over here, you'll end up with this equality, which is these two can be combined into just one equality. Look closely over there. Okay, great. So you would agree with me on that no, this we can simplify this entire thing to just one statement over here. And we know that maximizing 2 by W is equal to minimizing W by 2, because maximizing is for losers. We know how to minimize something, right? So that's what we'll do. And if you think properly, if there is a green point over here, now can you think, is it even possible if we don't do anything to our equality over here, if you still keep this optimization problem, will it be possible for us to find a blue line right in center over here if we don't do anything over here? Is it possible to come up with a linear classifier? Okay, so know this is not a bad example. So look close here. So there is this one red dot over here, and there is one green dot over here. Okay, and then there is a lot of green points over here, and there are a lot of red points over here. Okay, so is it audible now? Okay, so look closely at this data set over here. Don't try to look at the psi or the slack variable that I'm pointing out over here. Don't try to look at it. Just look at these points, the red points, the green points. Or let me even try to draw it over here so that it is a little bit more easier. So let me draw all these points, red, 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 red. Okay, and then you have cross, 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 cross over here, right? And there is one dot over here, right? There is one something from this class on the other side as well. Is it possible for us to draw just one line such that it will separate these two classes? Is it possible for us? So let's just give it a few seconds. It might get stabilized. And let me know when the video is stable for you. Okay, so for Nitesh, it is. All right, so here's my question to you guys, that look through the data set over here. There are some dots that I have drawn and there are some crosses that I have drawn. Is it possible for us to draw a line such that it will separate both these two classes? Will our optimization objective that we are trying to do? Nitesh says yes. So Nitesh, where can we draw such a line that will separate both these two classes properly? So there are some red points over here. There are some crosses over here, and there is again a point over here. So there are dots and the crosses, and there is another dot over here. So yeah, it's not possible, right? So in that case, our optimization objective that we are trying to do, it will fall apart, right? So it is not possible to find such a line that will maximize the distance, yet no, classify everything properly. So what we are saying is, let's introduce some error terms in our model. Okay, we loosen our model a little so that we allow for some errors. There will be some noisy data points always in our, or if you have 1 million points, there are good chances that there are some points which are lying on the other side and some points on this side. But what you want to do is look at the majority of the points as well and allow for some error. And that's what the soft SVM is. It is also called as soft SVM, which allows for some errors to into your system. And that's how we introduce, that's where we introduce the term regularization parameter, which is the C, which is the number of times you can allow the error. And in this case, psi over here, which is how much error do you want to, right? So this will be, you want this term to be as small as possible, but we can't always have this set to 0, right? So if you set C to 0, that is a hard SVM, or there is no margin for error. If you allow for some errors, if you set C to 0.1 or something in that range, you can and again, this is a hyperparameter. You can't really, your model can't find it for you. You need to try some experiments on your data set and run it through and set the regularization parameter such that it works good on your data set. Okay, so let's also look at this in action over here. Before we do that, let's just cover the linearly non-separable case as well. So what I'm saying over here is, given a data set over here. Now this was not separable in 2 dimensions, right? So in 1 dimension, this data set was not separable. You have it was not linearly separable. You can't draw a line over here such that it will separate both these 2 classes properly. In that case, what we need to do is, now in this case, what you could do is pass this through a kernel, and this kernel over here will transform this 1-dimensional space to 2-dimensional space. So in this case, the kernel was f of x is x square. Okay, so it was just a transformation from x to x square. And if you consider now x and x square both, you would see that now it becomes linearly separable. And again, same for 2 dimensions to 3 dimensions as well. In this case, it was not possible for us to draw a line so that will separate both these 2 classes. But if you pass it through an radial basis function or a Gaussian kernel over there, your points get raised on a hill. So the things which were centered got raised on the top of this hill on the Gaussian surface. And now you can draw a linear separator. You can still use SVM to separate both these 2 classes. Okay, does that make sense? On if the data is not linearly separable, how do we go about still using the same models that we know of? You could still use logistic regression. You could still use support vector machines and any other classifiers that you want. The only thing that you need to do is also consider some higher dimensional representations. So Nitesh, this is the case where it is not separable linearly. But if you mean that, is there a case where we can not separate them linearly even after considering more dimensions? No. You will always have, given that you have enough, I'm not saying that only from 1 dimension to 2 dimensions, there could be a data set which needs more than 2 dimensions as well. But given the liberty of having as many dimensions as you want, you can always, is a theorem that we will study when we go into next week, when we start with our neural networks as well, that neural networks are universal approximators. And the reason for that is they, given a set of infinite feature space that you have, you can always come up with a separator which will separate both any of these classes. And if you want to think about it, it ties back to what we had studied in our digital logic design classes, when you could always approximate a function through XOR gates, right? Some of NAND and NOT gates, NAND and NOR gates as well, right? So these were the universal gates. So always you could come up with a configuration of these gates such that you can approximate that function. And that is something similar going on over here as well. That given infinite number of, if I were given you 2 NAND gates and told you that can you derive any function using 2 NAND gates only, you could say no. But if I said you take infinite number of NAND gates, which are universal gates, can you come up with always a configuration that will satisfy that equation? Yes. And that is something similar going on over here as well. If I give you infinite set of dimensions to work with, you'll always come up with a configuration that will work. Does that make sense? So I'm not saying that just from 2 dimensions, you will be able to always come up with a line that will be best separating. But if you have enough dimensions, you can always do that. Yes, exactly, Sudeep. So that will, as many dimensions as you add, it will overfit your data. Okay, so eventually you will reach to a point wherein you are just trying to look for that particular point. And that's also called as the curse of dimensionality, wherein you don't want to keep adding a lot of data, feature space to your data. So that is not something that you ideally want, but there is always a trade-off, right? So you want to add only as much dimensions and also allow for some errors, because if you don't allow for some errors, then you will always overfit. Does that make sense? All right, so let's look at this in action as well. So I have, no, someone else has created a nice demo for support vector machines on their blog over here. So let me just share over here, share this link with you, and we can try to play with SVM online as well in our browser as well. So that will be pretty cool. So go ahead and check this out. Go to this page. You'll reach to this place over here. This guy has also given a good no, mathematical intuition behind SVM. Some of these things that we have already seen over here, that we want to maximize 2 by W and so on. The only thing that we haven't covered is how do you do the differentiation of this 2 by W term, okay? And that turns out to be not an easy derivation for us, not just in terms of no time, but also something that if you would want to refer, it's a good resource over here for you, that how do you take the derivative of this problem over here, right? So because the whole objective is to find how to adjust your W's, how to adjust your parameters such that you minimize W by 2 and yet make the correct predictions. But today I want you to come over here to the demo part over here, and let me know once you are in this demo section. So you can try SVM in the browser over here. I'm drawing some pluses over here, and this is the second class. So these are classes, and support vector machine is trying to come up with a line which is right in middle over here, okay, of these two classes. But there are some errors that it is allowing, and that's why you could see that as you increase the C, it will adjust the line accordingly. Okay, so over here it is right in middle. If you allow for some, you can change the C and now see how the decision boundary changes. Okay, and let's say if there is this +1 on this side. Now this is not linearly separable case, right? I just drew 1 plus on the other side of the boundary. But if you allow for some error over there, now you could still see that by allowing just one error over there, I was able to still create a decision boundary such that it is generalizing the problem quite well. So try it out in your browser and see how changing the C is affecting your model as well. And we can also try out the non-linear separable case. So linearly not separable case. Yeah, it could be. So over here, I'm drawing a linearly not separable case over here. Right, so there isn't a way for us to draw a line such that it will separate both these two classes, right? Right. In that case, what I could do is add a RBF kernel over here. And if I add an RBF kernel, you can also adjust the sigma over here to adjust the parameters on how we are classifying. And with sigma is 0.7, it seems like this could be a good decision boundary, saying that everything which is inside this circle are minuses and everything outside is the pluses. Okay, so try that one out as well for linearly not separable cases. And there is this polynomial function as well, wherein you are adding x to the nth power terms to your equation over there before you fit the model. All right, so let me know once you have tried it out. And you should try to make such demos as well. That is something that I have learned over time, that uh, just writing machine learning algorithms and the programs, no, that doesn't help you to remember them for a longer term. But if you create a demo out of it, no, it helps you a lot. And it's also interesting for other people to look at your work. So once you are done with that, go ahead and go to your course page over there. Go to your course page and download the files that we are going to work on today. So go to the bottom over here and you should see SVM, and below that you should see digit recognition with SVM. So download the assets from that Google Drive link. So go ahead and download that zip file. And once you've downloaded it, move to a place where you want to work with. So this is the zip file for me over here. And here's the digit recognition folder that I have extracted. Let me know if you are able to watch this, look at this properly. Okay, and let me know once you have downloaded and extracted the contents of the zip file. Okay, so Sudipto is done as well. Nitesh, are you ready as well? Okay. So let's look at the contents of this zip file first, and let me make sure that you understand what is going on with all these files over here. Okay. So the first thing that I have for you over here is the SVM, or the, I want to say, the screen capture.py. Okay. Or even before that, let's look at the original images folder. So in the original images folder, I have several folders for you, which has the digits that we are trying to work with, right? So I have the digit 0 over here. So 0, 1, 2, 3, and so on. Okay. For each class that we are going to work with, I have about 40 images that I have drawn on my, using a editor like Notepad. You could build something for yourself as well. But today we'll be working on these 4 classes over here. And our job will be to make a digit recognition system that can recognize these 4 digits. Okay. So usually what happens is, when you study machine learning, there is this famous data set called MNIST data set. Okay. Let me make sure that I write it down for you over here. So the MNIST data set is a popular data set, which is again the original use case when SVM was invented, they were trying it on handwritten digits. And that's why I'm also using SVM on handwritten digits, because that was initially when people started seeing that SVMs were really powerful, because in those days it was not possible to recognize handwritten digits with the other classifiers which were present. And suddenly someone came up with SVM and it was working really well. So if you use the SVM on the MNIST data set, now you will also get similar results to what we are going to do today, but you might not be able to try it out on your own handwriting, right? And that's the reason I'm trying to do this right from scratch. We are building our own data set. We'll see how to pre-process the files so that in future, if you want to build something else, let's say if you want to build a character recognition system, you want to recognize whether this is a letter A through Z, right? You could build those things by yourself as well. So this doesn't only work for digit recognition, but it will work for any pattern recognition in general. Does that make sense? And that's why we are doing it from scratch and not using something which is already available. But it is a benchmark data set, right? So if you're trying to compare your model with something else, you shouldn't try it out with a data set that you have made by yourself, but rather you would do it on a standard data set or something which is a benchmark. But for us, I'm more interested in showing you how you can do it end to end, right from pre-processing the images to building your model. Okay, everyone with me over here? So these are the images that we have. And then I have in the original images folder, we have all these things. Then what we also have is the screen capture, which was used to create these original images. Okay, so the screen capture.py file, this is not something that we are going to write today. I have written this for you. You can just go over it. There is no rocket science behind it. If you have this py screenshot module installed, you'll just be able to write these 4 lines of code, wherein I'm trying to capture these images from the top left corner of my screen. So from the top left corner of my screen, I'm going to capture each image inside a for loop and save it inside the original images folder. Okay, that's how I'm creating this. That's how I've created this original image folder, is by running the screen capture.py for different classes. So first I did for 0, then I did for 1, and then 2, and so on. Okay. So does everyone understand how did we create the original images folder? Is by drawing something over here on the top left corner of your screen, and then running the script which will capture multiple images of that thing over and over again. It will wait for 7 seconds, then you erase it, then you write something again, and it will keep on capturing those images in your original images folder. Okay, so no rocket science over there, just a for loop which captures this part, the left corner of your screen, and then saves it as an image. So that is not something that I'm going to write in our today's class. So that's the background on how this folder was generated. The next thing that we will do is we will generate our data set, because by now, till now, we have been used to working with CSV files. So why not convert the image files that we have to a representation that we are much familiar to work with, which are the CSV files. So in the CSV folder, you have the dataset.csv, which is generated for you. This is generated from a previous class. So you can also go ahead and delete this if you want. We are going to do this today as well, but otherwise you can keep it over there. I'm going to move it to the trash. Okay, I don't want the CSV file. I'll generate the CSV file right now in the class. Okay. And then you have some temp folders. Don't worry about that. And then you have the classification complete. After this class, if you want to look at the completed file, this is the classification completed file. This is the solution key as such. And over here, we are gonna, and this is the predictor live. So you must have seen a demo that I had shown you during the demo class as well. And it's on our YouTube channel as well. So if you want to build a real-time digit recognition system, you could run the predictor live script, which will do everything essentially the same that we have done, that we'll be doing in our today's class, but which is online. It is not offline as such. Okay, so you can go ahead and check out that script as well. Again, it's not anything new. We'll be building all the components within this file in the class, but it is the live version of what we will be doing. And let me go through the steps on the PowerPoint slide over here so that it is much more clear on what will be our approach be to building the digit recognition system. So the first thing that we are going to do is we will convert all the images, the original images folder that I just showed you, right? So all our images are in the original images folder. We'll iterate through all the folders and all the images within this folder to create our csv/dataset.csv file. Okay, so within the CSV folder, I'm going to store dataset.csv file, and I'm going to take the first column over here as a label, which is 0, 1, 2, and so on. And in the rest, 783 columns or 784 columns, 0 through 783, which is a 28 by 28 image over here, right? So each image you will convert it to a 28 by 28 size and then store it in a CSV file as a ones and zeros. Let me know you are still with me over here. Do you guys understand what are we going to do for our data preparation? You're going to flatten these images out. We'll take this grid of 28 cross 28 and we'll put each image in one row of the CSV file. Let me know if you are still with me. So Sudipto, all clear until now on how are we going to flatten the images? We'll take the image 28 by 28 and we'll put that in one row of the CSV file. Okay. Once we have the CSV file, the rest of the steps we have done before in our class as well. Okay. Because if you have the first row as the label on what you're trying to predict, and then you have these are the features, right? Over here, I am having 783, no, pixel 0 to 783. So how many features are we working with? Yeah, 784 features. And can you look through your dataset folders and can you tell me approximately how many instances or examples that we have for each class? Approximately how many training instances do we have for each class? So look through your folder, original images folder, and tell me approximately how many instances do you have for each class? Yeah, about 39, 40. That is what we have for each class. You have that many training examples. Okay. And that's how you'll see that SVM is so powerful that even with just 40 examples of each class and you still have 784 features, which is huge, right? You would be still able to make a classifier which works decent, right? Which works reasonably well. So that's how powerful SVM classifiers are, is you could use them with training examples where you have a lot of features, but not that many examples. So if you try to train a neural network with this thing, it might not work. It will definitely not work because neural networks, as we'll see in our coming module and next week, is that it needs a lot of examples, right? You need thousands and more data points for it to work properly, but support vector machines work reasonably well even with when you have less number of training samples. Okay. And over here, what you're going to do is first generate the model/svm file. So we'll store the model that we generate. We'll save it to a file where in the model folder. And then during the prediction phase, what we'll do is, again, you have the test image. You can't feed an image to our model. You need to convert that to pixels, or you want the vector representation of it, right? And that's how you'll do it. And note over here that I'm going to convert everything to black and white image. Okay, so the image over there which you have in the original images folder, this is it looks like a black and white image, but no, if you look at the properties of that file, it's a normal regular RGB image. Okay, so we'll have to convert it to ones and zeros. So we'll threshold it somehow so that all whites are maybe 1 and all blacks are 0. So we'll threshold it, and then we'll now ask our saved model, hey, what is this test image? And based on the model that we have built, we'll get the predictions. Tell me if you are with me on this one and if you understood what is the overall flow of the project going to be. 3 steps. First will be data preparation. We'll convert the images, flatten it to a pixel of, each image will become one row of our CSV file. We'll flatten it out. Then we'll build the model using scikit-learn, and we'll use SVM model, and then we'll make predictions using the SVM model. Everyone with me until here? Okay, great. Right, so let's go ahead and do the first step over here, which is preparing the data for our job. So let's come over here. I'm going to open a new Sublime text file. So go ahead and do that as well. So I'm going to convert, open a new Sublime text file. I'm going to save as, and I'm going to go inside the same folder over here, which is digit record. And I'm going to say generate underscore dataset. Okay. So generate underscore dataset.py. Maybe we already have that name over here. So I'm going to say create dataset.py. Okay. So the completed answer to that this problem is inside generate dataset.py. Just to give you a different name, I'm using create underscore dataset.py. Okay. So if you want to look at the answer on how to do that, it is inside generate dataset.py. Don't look at that. Let's write it by ourselves. I hope by now the OpenCV and the other library that I had asked you to install is installed on your system. Okay, so what's the first task that we need to do? We need to go over all the images, right? So all our images are inside the original images folder. I want to go over all these images which are located inside all these folders. Can you go ahead and try it out on how can we do that in Python? I think in our previous exercises, you must have already done this. So step 1, on to iterate recursively through all folders and files in the original images folder. Can you go ahead and try it out? So Sudipto, it shouldn't matter really. Now, whether you are on Windows or now you are Mac, it doesn't matter because Python and the modules that you have will, yeah, if you import OS, yes, there might be slight differences, and that's the reason you generally tend to avoid that module. But again, OS over there will have some, the reason why that package exists is to provide that abstraction, right? So it shouldn't matter much. And I have used the same OS methods on Windows as well as Linux, and on Mac as well. So it hasn't affected me a lot. And if you guys want to stay consistent with what I'm going to do, okay, so as a hint over there, I'm going to use the glob module. Okay, so it's called as glob, and there are a lot of ways to do this. Okay, I'm not saying that you have to use this, but this is what I prefer when iterating through directories. All right, guys. So here's how I am gonna go about iterating through the directories over here. And again, there are several ways to do this, but now here's one that I generally use. So I want the list of directories over here. So I'm gonna call this as a directory list. And what you could do is use the glob module, as I said. So you could say glob.glob, and I want everything inside my original images folder, right? So I'm gonna say original images. This is the folder name that we have over there, and slash, I want to go inside the 0 folder, but I'm going to keep it as a variable over here because now we need to go through various folders. If you want, you could do this recursively multiple times as well, or you could do it for one folder at a time. Right now, as I said, now I want to go through iteratively through all the folders, but I'm cheating over here a little and just going through one folder at a time. Okay, so I'm going to say label over here. Ideally, I want to go through all the folders at one go and do everything, but just to keep it simple right now, I'm just going through the folder name 0 first, and then I can say slash, I want to say star.png over here. Okay, so all the PNG files inside this folder, I'm going to go through original images slash 0. The reason why I'm putting in the label as a variable over here, because I can then change to 0, then I can say 1, 2, and 3, so on. Ideally, I want to do this in just one pass of the glob method over here, but just to keep it simple and to show you one step at a time, we are doing first the 0th folder. So let's just go to the 0th folder for now. Okay. And you could do it recursively, as I said, using the glob module. You could iterate through the entire folder. Okay, so let's see what do I have in the directory list. Let's just print the directory list out over here. Let's see if I'm getting all the, yeah. So I'm getting all the image in the 0th folder. So original image /0/8 and so on. I'm getting a list of all the files inside this here. So once I have the list of files over here, what we could say is for image path in directory list. Okay, once I have this list of files that I want to process, I can come over here and let's read this file. Okay, so what we are going to do is we are going to use OpenCV, which is Open Computer Vision Library, to reprocess all the data files that we have. Okay, and there are several ways to do this. You could do this using NumPy, you could do it using Matplotlib as well, but OpenCV is the most flexible in terms of it allows you to do some much more advanced operations as well, very easily. So a lot of times if you're working with images, I generally prefer to do this using OpenCV rather than just sticking with Matplotlib or NumPy. Okay, you can do it using those modules as well, which you already know, but OpenCV will allow you to do much more flexible. It is much more flexible because it is built for working with images, right? And I have a complete video on getting started with computer vision as well. So if you check the YouTube channel, I'll send you the link at the end of the class as well, wherein I walk you through each and every step of the computer vision, basic steps in a computer vision operations. Right? So using OpenCV. So if you're interested, you can look at that as well. But over here, I'm going to use OpenCV to read the image that I have over here, which is original images /0/8 and so on. So can you go ahead and look online, which method from OpenCV can we use to read a file, read an image file using OpenCV? So task is, so read image file using OpenCV. So what this will do is read the image that you have .png file and convert it to a matrix or an array of ones and zeros that that we can work with. So this will read the image, whatever it is, JPEG, PNG, it will convert it to a NumPy array that we can work with. So can you go ahead and search online which method from OpenCV can we use to read the image file? Yep, Nitish, that is correct. We could use the IMRead method from the CV2 module, which will allow us to read the image file, right? So let me go ahead and do that. So I'm going to come over here and let's say image is equal to cv2.imread. This will read the image in whatever extension you give it, right? So it allows for PNG, JPEG, bitmap, and so on. It will take care of that abstraction, right? So each format is different, but your IMRead module will return a consistent object after it has read that file. Okay. So we need to pass the image path, right, which is inside our folder. So I want to say IMRead, and the one thing that I'm going to do over here is pass a 0 flag over here. Okay, if you look at the documentation, you will see that you pass a zero flag when you want to read it as a grayscale image. Okay, I don't want a color image because the color information is not valuable to us. All I care is the black and white levels, right? And you see that I'm gonna even convert it to, right now this is a grayscale image, but we'll also convert it to a black and white image. Grayscale image will have variations from 0 to 255 levels of gray, but a black and white image will have only two levels, 0 and 1, right? So you'll have only two pixels, 0 or 1. So over here, I'm going to read the image as grayscale image. Okay. Everyone with me until over here? I'm just reading the image using the cv2.im read and passing a zero over here. Zero over here, if you look at the documentation, means that I want to read it as a grayscale image. Are you with me? Okay, let me also show it to you in a window over here so that you trust me that we are reading the image properly. So let's go ahead and show it inside a window that we can look at. So what I could say is cv2.imshow. This will show the image that we just read over here. And let's give it the window name. So this could be just any window name. This is the window name. It doesn't matter. And give it the image that you just read. Okay. And just one thing that you need to make sure is this window will go away immediately. So what we'll do is say also cv2 wait key. Okay, so this is similar to in C language, when we were doing get char or get ch. Have you guys heard of it? Get ch. When we would like pause over there until someone presses an escape key, something like that. Right, so this is what we are doing over here. cv2 wait key is a good way to substitute of get ch in Python. If you get stuck in a if you want your program to stop until someone presses a key, that's what we'll do, because otherwise the window will come and go away quickly, and that's why I'm just saying cv2.wait key over here. Okay, and I don't want to keep showing this window forever. Let's just see the first image, right? And we'll just break out of the loop after that. Otherwise, what this will do is we'll keep on running for all the images. I don't want to see that many images. I'm just saying a break over here so that I see only first image over there. Let's see if this works. So we need to import cv2 first. Okay, so go over here and import cv2. Okay, and as I said, we are indeed reading this properly. We are reading this file, which is inside our folder. This is the first image which was read, the zero, which has a zero in it. And let's close this now. And it should break out of it. Actually, not close it. You need to escape out of it. Okay, so if you put an escape over there, it might get, it will go over there. Try it out and let me know if you are reading the first file properly over there. Okay, so once we have read this file, the other thing that you also want to do is, right now this image is quite big. Okay, this could be something like 256 or 512, even more pixels. I'm not sure how big that what is the image size, but if we try to play with those many features, we'll not get good results. Okay, what we could also do is reduce the size of the image, wherein it is visible to some extent. Okay, it's not that bad, but it's not that big of a file as well, right? So if you deal with 512 cross 512 dimensions, then it will be too large for our SVM to deal with. What I said what I told you was, we'll just deal with 784 features, right? So 784 features, that means the image size has to be, if I want 784 features over there, the image size will be, so what should I keep my image size? Yeah, 28 cross 28, right? So that's what we will do. We'll resize the image so that it is 28 by 28. So let me go ahead and resize the image. Now this is a little tricky, so I'm doing it for you. But again, as now if you go and search on Google, you will find the method from CV2 which will help you resize the image as well. Okay, it is not that difficult. So I'm just going to say cv2.resize. I'm going to pass the image that I just got and then say 28 cross 28, which is the dimensions that I want. And the another thing that I'm going to do is now tell it how to do the interpolation. Okay, so this is when you are increasing or decreasing your file size, the pixel size. You want to tell your OpenCV now what kind of interpolation method you want to use. So there are some 2 or 3 types that you could use, and you can play around with some options over there. Okay, so go ahead and look at the documentation of cv2.resize, and you'll see that there are some interpolation options which are present. I think by default it is this one, but just to make sure I'm giving the inter area. And there are some descriptions on the documentation on how each one is different. It is now when you are increasing your pixels or image, or when you are reducing it, there has to be something which has to be filled in or dropped out, right? So how do you go about dropping out that pixel? This is what you are suggesting in the interpolation form over here. We're telling OpenCV that this is how I want you to interpolate my image. So if I do this now, and if I do again a break over here, let's see if I'm getting a smaller image now. Yeah, definitely we have much smaller image. As you see, we lost some clarity over there, but we'll see that now this will still be able to work with this image irrespective of the size. We can work with this reasonable amount of information which is present in the small image as well. Okay, everyone with me until here? Okay. All right. So the last thing that we want to do is, once we have formatted this, so Sudipto, just make sure that you have the image, the same variable name which is being reassigned over here. So this should be image, this should be image, this should be image, and you're displaying the image as well. Okay. If you have all those variable names properly, it should work. Yeah, it returns a new image. It's not in place. Okay. All right. So the final thing that we need to do is, now that we have the smaller image, all I have to do is just put it somehow to a CSV file. Okay. So we need to flatten this 28 cross 28 grid into one line of our CSV. So again, there are so many different ways of doing it. You could use a different, maybe you could do it in a data frame as well. Okay. I'm going to stick to very basic format over here. I'm just going to do it in a for loop, as simple as that. I'm not going to do anything fancy over here. Okay. I'm just going to collect everything. I'm going to flatten it. You can use the numpy.reshape method as well. The only reason why I'm not using numpy.reshape to flatten this 28 cross 28 into just one row is that I want to do some thresholding over there as well. I want to convert it to black and white. Right now we have this grayscale image, right? This returns a grayscale. I want to convert it to black and white. And that's why I'm doing it inside a for loop. Okay. So I'm going to do it in a for loop. I'm going to take this 28. I'm going to iterate through this 28 cross 28 matrix and convert it to one row. So let's see how I'm going to do it. What we could say is, let's start off with the data array that we want to build. So this is a list that I'm going to put all my values into. I'm going to say data.append. The first thing in my first row over here, as I had shown you, is the first thing inside this data is the label column, right? So which is label 0, 1, 2, 3, and so on. So I'm going to say I'm going to append the label over there. So I'm going to say data.append label. And where is this label coming from? So label is right over here, right? So label is 0, so it will get appended to, so now my data will look something like 0. Okay, with me until over here, I'm just saying data.append label. All I have done is append this label to the empty list over here. Or you could also start off with label like this, but anyways. Okay, so now I'm going to say, I want to iterate through this image over here, right? I want to iterate through this image. What I'm going to say is find the size, the height and the width of this image. I know that this is 28 by 28, so I can do it just like that. Or if you want to keep it dynamic so that whenever you change something over here, you don't have to change 28 everywhere. And that's why I'm just doing this. If you know that this is always going to be 28, 28, you don't have to do this. But let's just keep it dynamic enough. So you could say rows.column is equal to image.shape. Okay. So I'm trying to find how big is my image. So I'm saying rows.columns, this image.shape. So this ideally for our case, this will be 28 by 28. For us, it will be 28, 28. And then I'm going to say for I in rows, for j in range columns, value of that pixel is image of I comma j. Let me know if you agree with me on this one. All I'm doing is iterating through this 28 cross 28 image, and I'm saying that first find how big that image is and how wide that image is. So rows column will give me the how much should be the range of I and how much should be the range of j. And I'm saying the value at that pixel is you index inside this image array and get the value of ith comma jth column. Okay, so this is not any complicated. Let's just make sure that you understand this. And if I have an image over here, okay, if I have this image over here, and this is 28 cross 28, I'm starting from the ith column over there, right? So I'm starting from 0, 0 to entire row. I'm going through the entire row. Then I'm saying go for each row, then go for each column as well. So I'm just saying for each row, for each column, get the value of that pixel. Everyone with me until over here? What are we doing inside this for loop? I'm trying to get the value of a pixel at within this 28 cross 28 grid. Because remember, the entire image has to be one row of my CSV file, right? So that's what I'm trying to do. I'm trying to flatten this to 28 cross 28 into just one row of 784 values. Okay, with me? And then we could say data.append value. Okay, so this will flatten it out. So in this, if I come out of these two for loops, inside my data, I should have something like the value of pixel 0, pixel 1, 2, so on, and until 784th pixel. Does everyone agree with me on that one? So this will be pixel value of 0, what is 1, 2, and so on until 784 or 783 if I start from 0. Okay. The only thing that I don't like over here is this values over here. If this is a grayscale image, can you tell me what will be the range of values in this one? If this is a grayscale image, can this be 200, 100? Can this be 100, 255, 0, 100, 90, so on. In this data grid over here, I can have all the values from 0 to 255. Do you agree with me on that? So what I could do is, I don't want that. I just want the black and white image value, right? I want to threshold it such that now either I have 1 or 0, because there is not much information in the levels of gray. Even if I get a black and white 0, that is much more useful, and that will help me reduce the feature size as well, right? In that sense, my the amount of information that my machine learning model has to process is less. So I'm thresholding the value over here. So what I could simply do is just say, look at this, and if you tell me if you agree with me on this one, I could say if value is greater than 100, then I could threshold it to say value is 1. Else, I could say value is 0. Okay, so what I'm saying is threshold anything above 100, I'm saying put that as 1. Anything below 100, put that as 0. Will this work? Now, will I get a black and white grid over there then? Okay. So, all right. So the last thing that I want to do is let's go to the top over here, and let's also import the CSV module. So I'm going to import the CSV module for writing this to CSV file so that it is a little easier. Okay. So here's a CSV module. Yeah, it looks like a 0 there, right? That's pretty cool. There are those ones over there, right over here in the chat box. So let's import the CSV module and let's write it to our CSV file. So I imported the CSV module, and then let's also give the name of the file out. So I'm going to say file out is equal to open. I'm going to say dataset. I'm going to put it inside the CSV folder, dataset.csv file. And I'm going to use the append mode over here. Okay. The reason why I'm using an append mode is because I have to do it for various labels. So first I'll start with 0, then 1, and so on. That's why I want to append to the same CSV file. That's why I'm using the append mode for opening this file, so that it doesn't create a new file every time I run the script. I want to append to the same file. And then I'm going to say writer is equal to csv.writer. Okay, and this can be file out. Okay, and then at the end over here, I just have to say writer.write row. And guys, we have done this in the past, and that's why I'm just speeding a little through this step over here. When we were doing with Python intermediate, and no, I think you have done this in your exercise as well. You have used the CSV module before. So that's why I'm now going a little bit fast over here, so that we get much more time when we are doing the SVM model. Okay, let's see if this works. Let's build this, and seems like it completed over there. So I'm gonna say, let's go over here and let's look at the CSV. And there is a CSV file which got generated. Okay, we can't really say what's going on over here. There are a lot of zeros, but we certainly got about 38, 0 to 1 to 38, 39 rows over there. Okay, so most of it is 0, but somewhere you should see also ones as well. Okay, so here are the ones. I was trying to see if I could see a 0 on the Excel sheet as well, but unfortunately not. Okay. If I do a conditional formatting on this one, then maybe yes. And color everything with red and blue, then we would be able to see the 0. But anyways, we were able to get the CSV file. Let me know once you reach to this point. Let me make sure I zoom out a little and you see the program as well. All right, guys, I hope you are able to see the screen properly now. If not, it might just take a few seconds and it might get stabilized. The last thing that I want to do over here is just write a header to the CSV file as well, because we want to, when we do the pandas data frame, when we read the data into a pandas data frame, it might be easier for us to, if the CSV file has a red header row over there, right? And it might be easier for us to look at the CSV file and see if we are getting the right values as well. So I'm just going to add a header to the CSV file over here. And again, there are a lot of ways to do this. I'm just going to use a pretty simple way for me to do it over here. So I'm just going to say label and then say for I in range. We have 784 values over here. So I'm going to say for I in range 784. I'm going to say header dot append pixel I. Okay, so it will be pixel 0, pixel 1, pixel 2, pixel 3, pixel 4, and so on until pixel 784. Okay. or until pixel 783, because this will go from 0 to 783. Okay. And then I'm going to say writer dot write row header as well. Okay. So this will write the header to the CSV file as well. Let's just delete the previous file that I have so that it creates a brand new file for us. So let's go over here again and let's see if this works now. So let's do it for label 0. And the other thing that I want to also do is also print something out over here so that I can see what is going on. Okay, so print image path. I'm going to say processing image path. Okay. So let's run this. So as you see, we processed everything in 0. And if you go and open the dataset.csv file now, so label pixel 0, pixel 1, pixel 2, pixel 3, and so on until we should get it until 784, right? So until pixel 783. So this is what we have in the dataset.csv file. So Sudipto is saying, I'm getting one black row in between. Where are we getting black row, Sudipto? I'm not sure what you mean by that. Or yeah, so where is the blank row? What? Are you sure that you are not? So make sure that no, this writer.write row over there is not inside. I'm trying to think where could this not write anything to your CSV file. So try it out and compare it with you already have a solution to this file as well in the generate_dataset.py file. So you're getting one row, then one blank row. So I'm pretty sure it has to do something with your for loop. Okay, so somewhere now inside your for loop, or maybe your writer.write row by default on Windows also adds a /n character. So you might want to look into the options over there to see. I don't want to add a /n after I do a write row. Okay, so if that is the case, you might want to delete that /n. But also try out, first thing that I'll do, also see the generate_dataset.py file, which has a solution or that will have the exact same script that I'll be writing. So if there is a case that works and yours doesn't, then it might be a problem with your script somewhere. You might be doing a silly mistake somewhere. So I'm going to do this for 0. Then I'm going to do it for 1 as well now. So now this is for the label 1. And then I'm going to do it for 2 as well. And then label 3. Okay, so now I have in the CSV file, I should have all the labels which I have processed and collected the information for. Oh, there is one mistake that we did. As you see, I don't want this label to be added after every iteration, right? So this is not something that we want. So let me delete this. What I should have done is deleted this header thing after the first one. So I'm going to do it for 0 first. So let's do it for 0. And then I don't want this header to be printed. Okay, I just want it to do once. So I don't want this header to go there. So I'm going to take this header and comment it out. And now I can do it for, I should have done it for 0 over there. So I'm going to remove it again. Let's do it properly this time. Hopefully I don't make any mistakes. So for 0, then I want it for 1, and for 1, I don't want the headers. So I don't want the headers to go out. Then this is for 1. Now I want it for 2 without the headers. And then I want it for 3 as well. Okay, now I should get a proper CSV file now. Okay, so this has for 0, 1, 2, and 3, and these on the x-axis over here, on the columns over here, I have all the features from 0 to 783, from pixel 0 to pixel 783. Okay, so does everyone understand how did we create this CSV file? On how did we pre-process our images to reach to a point where, which is something that we can now work with in our scikit-learn, something that we have already seen how to work with. What I would also suggest is, no, there's a lot of, it might be something which is now very mechanical in nature. So if you want, just looking at the time over here that we have, we are running a little behind. So if you want, you can go ahead and use the same CSV file that was given to you. So extract your zip file, digit recognition.zip. Okay, so if you are on Windows, make sure that you have the new line character set to null over there while you open your CSV file. But Sudipta, I've tried this on Windows as well, so I'm not pretty sure on what mistake are you doing. What you're doing is, now you are removing the new line character. Yeah, so that's what I'm saying, Nitesh as well. Nitesh is getting it as well. So I'm not sure that what mistake you are doing, but it should work without saying that. What you're doing is saying a file that, hey, this is the new line character, which is no empty space. So there is no new line character as such for me, but you're still writing that new line character somewhere in the loop. So that is something that you should not do. Okay, so look at the solution file and see where you are going wrong in that case. Okay. All right, so look at the, if you are not done processing the image, I hope at least you got to understood on how did I process the images to get the CSV file. Is everyone with me on that one? On, do you get a sense of how did we process the image files to get the CSV file? Okay, so once you understand that, what I would want you to do is actually use the same file that I'm using so that we all are consistent and no, you don't have any mistakes that you are doing, and so that things going in the next step is going wrong. So either if you're confident that your CSV file is working great, then all good. If you want, I suggest also that you can just use the CSV file that I have in the folder for you in the dataset.csv file. Okay. All right. So the last thing that we want to do is build the model. Okay. And what we will do is build the model using support vector machines. So let's go over here and go to the SVM starter file. So open this SVM starter template. And these are the things that you have already done in the past. So this is something that will go away quickly, right? So because you have done these things in the past. So go ahead and open the svm starter.py file. The first step, get the data from CSV file, separate the labels and features. So do the step 1 and step 2. You have done this in the past. And let me know once you are done. Read the CSV file in your pandas data frame, then separate the labels and the features. All right, guys, so here's how we'll go about doing it. Now, this is not something that we haven't done. We have done this several times in the past, so I'm just going to do it alongside you. So we have our data frame inside. Let me zoom in a little over here so that it is clear. So we have our data frame is equal to pd.read_csv. We have our file inside csv/dataset.csv folder. So we have our data frame inside the pd csv/dataset.csv location. Let's make sure that we are getting the entire data frame properly. So I'm going to say data frame.shape over here just to see how much of the rows that I have. Okay, so I have about 150 samples over there and 785 row columns, right? So 150 samples, 785 columns. The 785 is because the first column over there is for labels as well. So you have 784 pixels, right, for each image. All right, so let's separate our training and labels and the features. So I'm going to say x equals to data frame dot drop. I can drop the label from the x. I don't want the features to have the label inside them, right? So the first column over there, which is the label, I can drop it from the axis as 1, right? So this is the columns. The first column, which is of label, I want to drop it for my features. And then I have y equals to data frame of label, right? So in my x, I have the features. In my y, I have the labels. Let me know if that was straightforward. Guys, let me know once you are done over here and you are with me. So pretty much something that we have already done. All right, the next thing that I want to do is split my data. The next thing that I want to do is split my data into the training and test data points. Again, go ahead and do that. Can you split it into training and test data points? Split into training and test data. And as a hint, I don't want you to manually calculate the number. You could also use from scikit-learn, you can use the train test split method. Okay, so here's something that I'm importing. So train test split, use the train test split to split your data into training and test data points. So Nitesh, I'm not, Sudipta, I don't know, why do you think we need to group by? So there is nothing for us to group over here. in terms of being combining the labels or anything as such. So that is something that our train test split method will take care. Let me just explain you how. So what Sudipto is saying is, in the CSV file, if I do it manually and just take the first, let's say 100 rows or 127 rows, in the end I'm gonna left with only threes, right? What if I get only all twos and all ones? Is that what you mean, Sudipto, in my test data set? Then it is wrong, right? But when you use your train test split method, look at the options over there, the default parameters. It has a parameter which is called a shuffle, and shuffle is set to true by default. So it will always shuffle your training and test data points so that you don't end up in that situation. Okay, does that make sense? When you use your train test split method, there is a parameter over there which has shuffle, and that's always set to true by default. So X train, X test, Y train, and Y test. Okay, and we can say train test split. And we can give our X, we can give our Y. The test size over here, I can set it to 0.2 because I'll take 20% as my test data points. And I can say random state over here as well. Why am I saying random state? Because as I said, your train test split method will randomly split. But if I am doing something randomly, then you and I will get different results, right? And every time I run the script, I'll get different results as well. So if I want to fixate on just one random state, I can just add a random state equals to any number over here, and that will always assign, give me the same train test split. Okay, and that's why I'm using random state as 38. If I don't do it, my train test split will randomly shuffle my data. Every time I will get different results on accuracy, and you and I will get different results as well. So if you don't use it, you can try it, but you will get different results than me. Okay, so yeah, it's the seed of the random variable. It is exactly that. So internally, it will use that as a seed. Okay. All right. So the step 3 over here is just something that you could skip over here because we are running less on time. But if you look at the solution, I have given the step where I'm now also showing it in a window what the X train looks like. Okay, so you can plot it out and see what X train looks like, and make sure that X train and X test are is what you expect, and Y train and Y test are something that you expect. So you could try to do and plot it and see what these images looks like. But for now, because we are running a little short on time, I'm going to skip step 3, which is optional. Let's go ahead and build the model. Go ahead and try to do it. Build the model using SVM, scikit-learn SVM module. So I'm importing the SVM over here. I'm saying from sklearn import SVM. So you want to use the SVM classifier and use the X train, X test we just generated, and Y train and Y test to build the model. Let's look at the documentation over here, SVM, SVC, which is the scikit-learn support vector machine classifier. So you have svm.svc, where by default C, the regularization parameter that we just saw, is 0, kernel is set to RBF, and you have, let's say, yeah, C is 1.0 by default. So all the models in scikit-learn, they pretty much work the same way. So here's an example. It's a classifier is SVC. Gamma is auto classifier.fit, and then you could print the predictions, right? So I'm gonna do the same over here. I'm gonna say model is equal to svm dot svc, which is a support vector machine classifier. Now you could try by the default kernel, which is RBF as well. But once you do some experimentation, you'll see that the linear kernel will work much better for the sample data set that we have over here. But let's see. We'll start off with the default. We'll just keep everything constant and see how much accuracy did we get. And if we adjust a few things, are we getting a better result? Okay. So then I can say model.fit X train and Y train, because you need to give the training data to your model to work. We don't want to give a test data during the training. That's why we're giving the X train and the Y train. We've done this before. All right, so just one new thing that we are going to do today is we are also going to save the model, because it makes sense for us to not every time retrain our models when we want to do predictions, right? We want to save the model as well, which we have built. So what you could do is use now there are several ways to do it, but one popular way to do it is using what we call as joblib. Okay, with joblib you can dump any Python object to a CSV file or any a data file, and then you can read it again when you want to do the predictions. So it is not something which is specific to machine learning as such, but any Python object that you want to dump it on a file, you could use the joblib for that. Okay, so that's what I'm going to do. I'm going to use joblib.dump to save my model at this location. I'm going to save it as model / I'm going to say svm 4 label, because we have 4 labels over there, 0, 1, 2, and 3. Okay, saved my model over there, and let's make the predictions as well. Let's get the accuracy score of this model now. So I'm going to say print accuracy score is metrics dot accuracy score. I'm not sure if we did this before, but I think you should have done this when we did the naive Bayes classifier, right? We have a method in scikit-learn which gives us the score of a classifier, which is metrics. We are importing the metrics over here. Yeah, you could do model.score as well. Okay. I'm going to do matrix.accuracy score over here, which is y-test. And I'm going to do the predictions over here. Or you could let's do just model.score. Okay, let's try with model.score. So x-test and y-test. Okay. All right, let's see what is the accuracy score. And the accuracy score that we're getting is about 86% over here, right? There are some warnings that are getting printed. You can just avoid that using, if you say gamma is equal to auto over here, or set gamma explicitly to auto or scale, and that will get rid of that. So if you want to get rid of that warning over here, you could say gamma equals to auto. And yeah, just depends on the random state that you have chosen as well, and your data set that we generated. Okay. So for me, accuracy score is 86%. Not that bad, right? What we could also do is adjust some parameters over here. So let's say instead I want a linear kernel. Instead of, by default, it uses an RBF kernel. If I use a linear kernel, what will happen? Let's see. So it's even more now. With linear kernel, I'm getting even better results. And let's see if I adjust my C as well. If I, instead of C is by default is 1, if I say C is 2, then how is the accuracy score? It's about the same. If I say 10, it's same. It stays the same for me, surprisingly. So C is not having much effect. I hope we are not doing anything wrong over there. So gamma over here is the curvature of your sigma, right? So is that different? I hope sigma is not different than gamma over there. So let's look at the gamma over here. So it's an optional over here, which is the kernel coefficient for RBF. Okay. So when you say the current default of auto is 1 by number of features over here. So intuitively, if you want to understand what gamma will do is will define the curvature of this Gaussian slope. Okay. So by adjusting the gamma will make the hill narrower or wider. Does that make sense? It's a parameter of this kernel on how do you want to raise these points if you are using a RBF kernel or any nonlinear kernel. Okay. All right. So that was it for the digit recognition now class over here. I also want to show you a live demo that now you could build using the same model that we just created. Okay, so during over here, I'm not doing any predictions, but if you want to do predictions, you could use the predictor live script that I have for you. Let me show you if it is really working. Okay, so we have already created this model in SVM4 label. Okay, so let's use the SVM4 label. Is this our file? SVM4 label. So hopefully if that is the file, and if we come over here, so predictor live screen capture SVM starter. So we were in the SVM starter and we generated this file, which is SVM4 label, right? So we'll use SVM4 label over here in the predictor live. It is again doing the same steps as before, same things that we have already done. The only thing that I've done extra over here is doing a Gaussian blur, which is blurring that image. I don't want that. Let's remove that. Everything else should remain the same. Let's see if this works now. So I'm saying SVM4 label. I don't want a linear over here. Model SVM4 label. And yeah, let's try this script and let's see if this works. So I'm just using a tool to draw on my screen over here. There is no rocket science. It's a paint-like tool to draw something on your screen. Okay, I shouldn't have done that. This cursor is going to be a problem. Okay. All right, let's run the script and see if this works. Okay, so prediction is 0. Are you guys able to see my screen properly? All right, so prediction is 0. Let's see if we can do 1 over here. Yep, prediction is 1. That is working. If I do a 2, now this is going to be difficult. Let's see if 2 works. This is not working. Actually, I know why that is so. What we could also do is actually train a little more. Instead of using a train test split over there, let me just do this. So instead of not doing a train test split, I can also use the entire training set
for my predictions. So over here, I'm throwing away the 20% of my data, right? So I'm left with even less data. But for live testing, I'm throwing away my test points. I want everything in training. Okay. And now let's see if this works now. So I'm increasing my training size over here by reducing the test size. Does that make sense? For live predictions, I'm using all the data that I have for building the model itself. Now that will give me some errors because I don't have anything to for model.score over there, right? But no, the accuracy score is not printed, but that's okay. I should still get SVM4 label over here. Now let's see if this gives me better results. All right, let's run this. So by default, if there is nothing inside the box, we are getting a prediction as 1. Okay. If I do a 0, yep, prediction is 0. So 0 and 1 is working quite good. I think there is some problem with our 2 over there. Let's see. So there is some problem with 2, definitely. It's not working for me. Try it out if it works for you. So the warning is okay if you're getting just the warning, and we are getting the 3 properly as well. You see, I got the 3 properly as well. The 2 is not working for some reason. We might have some problems in our training data for 2. So go ahead and check it out. Let's see if I do a proper 2, if that works. Nope, it's not able to get the 2 properly. It still think it's 1. So try it out some different versions and see if you can improve this system that we have built. It generally works pretty good over here, but I'm not sure what's going wrong with the 2 class that we just used. So yes, Sudipta, you could use Paint. Just make sure that the same thing that you use for building the training set, you're using the similar tool for testing as well. So I use this for training, for creating those training images. We could use it for doing testing as well. Okay. So that's it for today's class, guys. I hope you enjoyed working on creating this. All right, so let me answer any questions that you might have. Sudipto says it's not working for you. So what are you trying, Sudipto, over there? Is it not running the live predictor live script? And look through the script over there. It's the same thing. Try to rewrite a few things according to what you understood. Okay, so that's a Windows thing, right? I have done this on a Windows machine as well. I'll share the script over there, which will help you overpass that. So go and try to Google out as well on what method is causing that problem. Yeah, sure, Nitesh. Go through the script. I'll share the Windows version of the script as well. It is just 1 or 2 lines of code that you have to change. Yeah, great. So share it with Nitesh as well on the chat on what was the line that you changed. You just have to add. Good. just by doing that it's working, then great. And again, guys, it's the same thing that we have used before. It is not something new that I have written. As you see, I'm just getting the image, then converting to grayscale. Then we are doing a threshold. Then we are writing that image to a temporary folder. And then just like we were doing, now creating the equals to range rows and j equals to range columns, we have done this. And then I'm just saying model.predict and giving X over here. Okay. So nothing new that we haven't done. It is just inside a live version now. It is inside a for loop now. Okay. All right, guys. So thanks again for coming. In our tomorrow's class, we'll try to go over some more classifiers and how you can combine different classifiers together as well to form even more classification classifiers. So, and next thing that I want to start after we finished our tomorrow's class is go into neural networks, because that is something which is very useful and powerful. So I don't want to leave it at the end. So we start off with the neural networks module as soon as we can. Okay, and it is so much more related to what we have done with logistic regression and so those things. So those things are really fresh in your head. So I want to cover neural networks as quickly as we can. All right, goodbye.